From a distance, this tiny, blindingly white moon of Saturn looks like a dead relic, a world so small it should have frozen solid billions of years ago. It is one of the brightest objects in the solar system, reflecting almost every photon of sunlight that hits it, which creates a surface that appears perfectly still and featureless. But as you move closer to the southern hemisphere, that stillness vanishes. The crust is torn open by four massive parallel fissures that shouldn't exist. These are deep blue canyons that act as active mechanical vents, screaming pressurized water vapor and organic material hundreds of miles into the vacuum. It wasn't until we analyzed the magnetic pull around Saturn that we realized what we were actually looking at. This wasn't simply just a moon, but more of a high-pressure hydrothermal engine. Enceladus, as they've named it, is effectively leaking its own interior into space, proving that beneath a pristine frozen shell, a global ocean is running at full power. Very few impact craters remain on this landscape, erased by a constant rain of falling ice crystals that have turned the surface into a soft, deep powder. Something is forcing the ocean out, and as of early 2026, we've realized that this leak makes exploring the deep sea fairly easy. The reason this moon makes exploration easier than others is the way the moon is plumbed. Most icy worlds are locked behind a frozen shell, but Enceladus functions like a global pressure cooker. New 2026 chemical models show that the interior ocean is heavily enriched with dissolved carbonates, producing a high-pressure soda ocean. This chemistry does more than just sit there. It also reacts with the moon's rocky core to produce hydrogen gas, which builds up immense internal tension. It's a self-pressurizing hydraulic engine. The pressure becomes so intense that the southern crust literally cannot hold it, forcing the ocean up into space. While we would normally need to build massive, multi-billion-dollar drilling rigs to reach a subsurface sea, Enceladus has already done the heavy lifting by launching its internal composition into a 300-mile-high spray that is perfectly positioned for orbital capture. This constant venting has created a secondary shortcut, Saturn's E-ring. Over 90% of the material in this massive ring is sourced directly from these plumes, meaning the moon has been depositing its internal data into a stable orbit for thousands of years. Just recently, analysis of these particles have shown a heavy concentration of silica and salts, minerals that only form when water interacts with a hot interior at temperatures above 200 degrees Fahrenheit. It changes the roadmap for future exploration. The engineering challenges of drilling through an ice shell are irrelevant here because the moon is already broadcasting its interior chemistry into space. The chemical broadcast recently revealed a structural component previously thought to be impossible for a moon this size. In early 2026, reanalysis of the plume's salt-rich grains confirmed a phosphorus concentration hundreds of times higher than that of Earth's oceans. Phosphorus is the fundamental bottleneck for energy transfer in biology, and on most worlds it remains locked away in deep-sea minerals. On Enceladus, the soda ocean chemistry functions as a powerful solvent, which strips phosphorus from the rocky core in dissolving it into the water. This moon has effectively pre-concentrated the rarest building blocks of a habitable system and delivered them into a cloud of ice crystals. It eliminates the need for complex deep-sea sampling probes because the internal chemistry is already doing the extraction and enrichment for us. The energy driving this system isn't sourced from the sun. Because the moon's orbit is slightly elliptical, Saturn's gravity is constantly kneading the rocky interior, a process of tidal heating that generates localized hotspots on the seafloor. These hydrothermal vents act as the primary pump for the entire moon. This vertical conveyor belt is what keeps the southern fractures from freezing shut, creating a high-speed pipeline from the deep crust rocks to the surface vents. By mapping the infrared signatures of the plumes, we've calculated a total thermal output of 54 gigawatts. That is the equivalent power of 66 million solar panels, proving that Enceladus is not a cooling relic, but a thermally active machine currently running at peak performance. This constant venting has turned Enceladus into the primary architect of the Saturnian environment. While the famous inner rings are composed of ancient, grinding debris, the massive outer E-ring is a dynamic construction built entirely from the moon's own interior. Every second, the south polar vents scream over 200 kilograms of water vapor and ice into the vacuum. Most of this material falls back as a fine, blindingly white powder, but about 10% escapes the moon's gravity. The moon is effectively exporting its own mass to surround the parent planet, all ending up creating a stable, orbiting repository of its deep-sea chemistry that we can sample without ever touching the surface. When you compare this to a world like Europa, the difference in accessibility is staggering. We've spent decades obsessed with the Jovian moons because of their sheer scale, but scale comes with a massive energy cost. Europa's ocean is locked behind a jagged, radiation-blasted shell that is estimated to be 18 miles thick. To even verify the chemistry of that sea, we have to land, stabilize, and drill through more ice than exists at our own North Pole. Enceladus, by contrast, is a cheat code. It is a fraction of the size, yet it provides a direct, high-pressure pipeline of its deepest secrets directly into our path. It has effectively bypassed the billion-dollar barrier of entry that stalls every other mission in the solar system. This accessibility is precisely why it now holds the highest potential for a second genesis. Europa has the water, but its energy exchange with the core is still a theoretical model. Enceladus is currently proving both in real time. We've detected the molecular hydrogen that proves its hydrothermal vents are active, and the massive phosphorus spike that proves its ocean is a concentrated chemical battery. It has proved that we don't need to fight the solar system to understand it. We just have to stop looking at the largest targets and start looking at the most efficient ones.